Intelligence, the final frontier. These are the field reports from Project Gepetto, a continuing mission to explore what emerges between human intuition and machine reasoning, and to boldly build what no single intelligence could create alone. Log entry 7. Mission status, orientation. A few months ago, this region was nearly empty. Now it is crowded with vessels, each charting the same territory with different instruments and considerable confidence. Before I commit Gepetto any further down its own course, proper bearings are required to see which of these ships actually know where they are and whether I shall trust anyone's map, including my own.
In the last episode, I laid out some external criteria for what Gepetto should actually be able to do. I only touched them briefly. The problem is that honest self-assessment becomes difficult when most of your thinking happens through AI systems that are structurally incentivized to agree with you or to move forward. And they rarely push back hard enough. That's why I need to look at what other people are actually building right now. Not because I expect to find something ready to use, but because staying inside my own small system for too long makes it easy to lose perspective on what is actually missing. So let's start with the first one. This is Odysseus. It calls itself a self-hosted AI workspace, and it showed up at the end of May. That curve is its GitHub stars over the first few weeks. Under the hood, it bundles a lot. A chat with planning agents that call tools and work through tasks. A cookbook that scans your hardware and serves models to match. Persistent memory across conversations. And those agents reach built-in tools, bash files, the web, plus any MCP server you connect. The reality check starts in the project's own documents. Odysseus tells users to treat it like an admin console. A logged-in admin can run a shell, read and write files, send email, control model serving. And the same system that advertises bash, files, web access and MCP also lists the missing shell and file system sandbox under its known gaps. Privacy turns out to be conditional too. In future stack reviews, packet capture, a local model chat, stayed on the machine, while the cloud model turn opened an external connection to OpenRouter. And the roadmap is just as direct about maturity. Cookbook reliability, agent prompt and context load, and a skilled tool prompt injection audit are still high priority work. This is OpenClaw. It presents itself as the AI that really does things. An assistant you reach through the chat app you already use. WhatsApp, Telegram, Slack, Discord, the interface is familiar. What changes is what sits behind it. The pitch is convenience. It remembers your preferences across conversations, it can browse the web and fill out forms. It reads and drafts your email and it lives in 29 chat channels, direct messages and group chats alike. Drawn out, the shape is simple. A familiar chat channel on one side, an agent and its tools in the middle, and your files, accounts and the network on the other. Again, the reality check starts in OpenClaw's own documentation. The page on local models opens with a section called Hardware Floor. For a comfortable local agent loop, 2 maxed out Mac Studios or an equivalent rig, around $30,000. A single 24 gig GPU only handles lighter prompts. The security page is blunter. For any bot that can run tools or touch files and networks, use the latest generation best tier model. Smaller tiers carry too much injection risk. If you must use one, disable web search, web fetch and the browser and keep the tools read-only. And the local model page finishes the thought. If it still misbehaves, drop to lean mode. Last resort. Turn tools off entirely. The agent then runs without tool calls. So the local path exists. Follow the docs, down it, and what's left at the bottom is a chat window. For a lot of people, it's the most familiar face of local AI, LM Studio. Pick a model, download it and open a chat. It's polished, it's free for home and work use, and it's also run a local server that other apps can talk to. The promise is stated plainly. Run AI models locally and privately. And the privacy policy is specific about it. Your messages, chat histories and documents stay on your device by default. The only times anything reaches the company are model searches, updates checks, or when you email them. It even says that because the app carries no telemetry, it can't produce a copy of your data or delete it. There's nothing to retrieve. Parts of it are open too. the command line tool and the JavaScript SDK sit on GitHub under an MIT license. LM Studio says the right things about privacy, and I found nothing to suggest otherwise. Network behavior can be tested from the outside with a packet capture. But that only proves what one version did in one setup on one day. The core application stays closed. In the terms, its structure, organization and source code are treated as trade secrets, and reverse engineering is restricted. To be fair, the engines underneath are open. The closed part is the layer around them, the desktop app, the catalog, the model management, the local server. So the one layer that carries the promise is the only layer nobody outside gets to read. OpenWebUI is the mature one in this survey. A self-hosted platform that runs models from Ollama or any OpenAI-compatible API with multiple users, permissions, knowledge bases, web search tools and extensions. It also has a memory layer that carries facts from one conversation to the next. Two pieces are worth separating here. Knowledge bases are where documents and collections live. OpenWebUI chunks them, searches them, and pulls the relevant parts in when a model needs them. Memory is its own layer. Facts, preferences, and context about you, kept across conversations. And with native tool calling, the model manages it directly. It can add a fact, search the memory bank, correct something it got wrong, delete what's no longer useful, and list what it already knows. Two ideas, two places in the system. The docs are honest about where that stops working. Autonomous memory management, they say, works best with frontier models. Small local models may store or retrieve information inconsistently and may not manage memory effectively on their own. There's no fallback either. Memory only exists in native mode, and native mode needs a model that can call tools reliable. The old prompt-based mode still exists, but it's marked unsupported and it can't reach memory at all. The docs are direct about the remedy. If a model struggles with native, the fix is a stronger tool calling model. So the layer that makes an assistant yours, the one you'd least want to send anywhere, is the layer that asks for the biggest model in the room. 4 systems, 4 different shapes, and one pressure that keeps returning. Ask for a chat window and local holes. Ask for an agent that acts, tools, memory judgment, and the system starts pointing somewhere bigger. OpenClaw names a hardware floor of $30,000 for a comfortable local agent loop. OpenWebUI says small local models handle memory inconsistently. Odysseus lists context load as open work. LM Studio never fully answers the question because it isn't built around an agent. But I'm not sure the models are the bottleneck. I've got a laptop with 24 gigs of VRAM and a Spark with 128 gigs of unified memory. And there are serious models that begin to fit those envelopes. Loading one is the easy part. An agent needs room to work, context for tool schemes, history and memory, throughput that keeps a multi-step loop bearable, headroom that doesn't collapse when the prompt grows. Maybe what those models are missing is the right environment. So the question I'd rather ask is this: are local models too limited for this kind of work? Or are these systems still designed as if a cloud model will eventually absorb their complexity? Either way, the constraint is the same. On a local model, every token in the prompt costs latency you can feel, which makes memory the harder half. OpenWebUI's docs describe a model that manages its own. On a frontier model, that works. On a small local one, it's inconsistent by their own account. So something has to decide what enters a prompt and what stays out. Where a fact came from, what happens when two of them disagree, and when something stops being true. The more judgment I hand over, the less of it I practice. A system that thinks for me makes me slower at thinking. I don't want a system that does my thinking. I want one that argues with me, one that holds the context I can't hold and leaves the judgment where the expertise already is. There is a 5th system I left out of this survey because it deserves a slower look. Hermes agent makes the strongest local claim I found today. Terminal, files, browsing, delegation, scheduling with the model running on your own hardware. It seems like a step further in this direction. So that one remains under observation. Gepetto is the path I'm taking. I don't know where it leads or whether the concepts hold. That's what the building is for. My view is shaped by my hardware, my workflow, and the AI systems I talk to every day. So I need field reports from outside my own loop. If you're running local models, agents or memory systems for real work, tell me what actually holds up. Which model, which system, which hardware boundary, and where it breaks.